Jai Hind. The today topic for the discussion is TRC, that is Tuple Relation Calculus, which is covered under Unit 2 of the subject DBMS with the code BMC 201. So before going towards the tuple relation calculus, we have already seen the concept of relation algebra. And in relation algebra, we have seen that is how to write the queries in the mathematical form. There we are discussing the various operators. For example, we discussed union operation, we discussed the selection operation, projection operation, we have seen the join operation and so on. In the case of the tuple relation calculus, what is happening, we are talking in terms of tuples, that is the instances or the rows, that is the data which is present in your database or in your table in a relation basically. So it is based on specifying a number of tuple variables, and each tuple variable usually ranges over a particular database relation, meaning that the variable may take as its value any individual tuple from the relation. So if we are having a relation R, for instance, and it is having attributes, for example, A1, A2, A3 up to AN. So in the case of here, the T, it specifies tuples. That is all the data which is present in this particular relation. And the syntax, the format in which we write the queries in the TRC is basically this format, where T is a tuple variable, CUND, that is condition, is the conditional expression which is working on this particular variable, that is T. And T basically it is an element of R, that is T, it is an element of R in the relation R. Later on we will see how to write the queries. So find, for example, find all the employees whose salary is above 10,000. So in this case, we are having a relation employee, and one of the attribute in this employee is the salary. Another attribute is the name, address, date of birth, so on. So if I look at this particular relation, I need to express this query in the TRC format. In the TRC format, what we have seen that we need this particular syntax. So here this is T and this is my conditional expression which is working on the tuple T. So once I am writing, first I will tell on which expression, on which relation I am working. So the relation here is my employee relation. So I have written the name of my relation. Then I am working on all the tuples. So here the T comes, and that is the logical operator. And on this particular relation, what I am doing, I am selecting only those tuples whose salary is greater than 10,000. So this is the way of writing, that is tuple and then attribute, whatever you want to address, and then operator, whatever operator you are using here, and then whatever be the expression. So here the attribute is salary and the operator in this case is greater than, and the expression is that is 10,000. Find out date of birth and address of the employee whose name is, in this case what I am doing, address, clear, and name is this. So we have earlier seen that in the case of my employee relation, these are the attributes I have already defined, and the name is further. It has further been classified as name first name, last name, middle name, I am having address, I am having date of birth, I am having salary. So now what the TRC says, in the TRC I need date of birth and address, and that what I have done. In this example, what is happening, I am taking all the attributes. Clear? So in this case, all the attributes, for instance, if these are the attributes in this relation R, then what is happening? All these attributes, that is, it is equivalent to something like this. Select asterisk from employee where salary is greater than 10,000. Clear? So here all the attributes would get selected. But in this case, in the second example, what I need, I only need two attributes, that is date of birth and address. And that is why I have used this notation. And whenever you are using these notations, always specify the tuple name. So here T corresponds to all the tuples of the relation employee. So here it implied that DOB and address, they are from which relation? They are from the relation employee. So here what is happening? Here what is happening? In this case, this is my T, and all this whole string, it corresponds to condition T. So here on which relation I am working? I am working on this relation, and what is the condition? The first name, it should be Mahesh, and middle name should be this, and last name should be this. And all these attributes, they need to be preceded by the tuple, that is T in this case. So what are the informations we need to specify in the TRC? After going through these two examples, we have seen that for each tuple variable T, range relation R of T, that is, you need to mention the range, that is on which relation you are working. The condition to select particular combination of the tuples, that is on which tuples you want to work, on which tuples you are applying the condition. The set of attributes to be retrieved, that is the requested attributes, and we have seen this becomes my range. These are the attributes, and these corresponds to my condition part. So after looking this, now my expression which we have seen in the earlier, you could say the simple expression T condition on the tuple T, it can be generalized as these are my attributes on which I need to work. Then always use this vertical bar. After this, condition, and it could be a combination of different condition. So a formula, when we say a formula, it is made up of predicate calculus atoms, which can be one of the following. That is, in the case of this particular query, what is happening? This is an atom, this is acting as an atom, here it is acting as an atom. So these are my atoms. An atom of the form RTI, that is in our previous example, employee T, where R is a relation name and TI is a tuple variable. This atom identifies the range. It will tell on that what is the range of my tuple variable Ti as the relation whose name is R. Another atom which we have seen, it is of the form Ti dot A operator, then Ti dot B. Now here it could be my constant, it could be my another relation also. So in this case OP is it is that is operator, it is any comparison operator. A is the attribute of the relation on which Ti ranges, and B in this case attribute of the relation on which Tj ranges. And in this case both A and B, they corresponds to the same relation as we have seen here. It could be from different relations also. We will see such examples later on. An atom of the form Ti dot A operator constant, as we have seen here. If you look here in this example, constant. So here we can say these are the atoms and the formula comprises of these atoms. So a formula is made up of one or more atoms which are connected via the logical expression, and these logical operations, they are permissible. Every atom in itself is a formula. If F1 and F2 are two formula, then F1 and F2, it is also a formula. If I apply the OR operator, it is also a formula, and these two are also my formulas. The truth value of these formulas are derived from their component formulas F1 and F2. And it says it is true if both F1 and F2, both my formulas, they are true, otherwise it is false. In the case of the OR operator, if both F1 and F2 are false, otherwise it is always true. That is, if both F1 and F2 are false, only then this particular formula is false, otherwise it is always true. Not F1 is true if F1 is false, that is, it is a complement of F1, and similarly not F2, it is a complement of F2. Now in TRC, quantifiers, they play a very important role, and in TRC we are having two important quantifiers. One is my existential quantifier and another one is my universal quantifier, and you have already seen such kind of quantifiers in maths, you have already studied there. So here also the meaning of these quantifiers, they are almost same, but the thing is that here we are using these quantifiers with respect to the tuple relational calculus. Existential quantifier, the symbol for the existential quantifier is this. Because of formula F, that is, we will use this notation. That is, there exists a tuple T in this formula F, and it is true if there exists some tuple that makes F true. This is very important. That is, there is some tuple which is present in my relation which is making this formula as true. The symbol, it is used for the universal quantifier, because every tuple in universe of tuples must make F true to make the quantifier formula true. What it says? It says that for all T, there is always, the formula F is always true for all the tuples T. Now, when we discuss the quantifiers, the tuples, we need to discuss the free and bound tuples also in a formula. Now, what are the free and bound tuples? A tuple variable T is bound if it is quantified. That is, if in a tuple, we are using these quantifiers, then we say that a tuple is a bounded tuple, otherwise it is a free tuple. So, we can define a tuple variable in a formula as free or bound according to the following rules. When we are discussing that a tuple is free or bound, we always see its concept corresponding to a particular formula, not corresponding to the whole expression. So, what it says an occurrence of a tuple variable in a formula f, that is an atom, is free in f. If we are saying, if we are having only formula f and it is working on a tuple t, then it is always a free tuple. But the condition is that it is a atom. An occurrence of a tuple variable t is free or bound in a formula made up of logical connectives. That is, it is only for a single formula, that is an atom formula. But we have seen that two atoms or two formulas, they can be connected by logical operators. So, if in this case we are having such kind of things, then how we decide that whether it is free or bound? If depend upon whether it is free or bound if F1 or F2, if it occurs in either one of them. So, if in F1, for example, F1 is working on tuple T and F2 is working on tuple W, and in F1, the tuple T is free, then we say that the tuple, although in this particular formula, this is, for instance, this is my bounded tuple and here I am having free tuple. But when I talk about the tuple T, then we say it is always a free tuple. And when we talk with respect to this particular tuple, we say it is a bounded tuple. So, in a formula, F1 and F2 or F1 or F2T may be free in F1 and bounded in F2 or vice versa. In this case, one occurrence of T is bound and one is free in F. So, when we talk about the free and bound tuple, we always see their freeness or their boundness with respect to the to a particular formula, to a particular atom. So, all free occurrences of a tuple variable T in F are bound in other formula F dash of the form. Maybe in one of the formula F, T is a free tuple, but in other formula, it may be a bounded tuple. And when we say a bounded tuple, so we should have such expressions present in that particular formula. For example, we are having three formulas. Here F1, here what the F1 says, that is D, it is my tuple. Okay, maybe I am having any relation R, having some attributes, and what we have done, we have represented this particular relation with the tuple D. So, here we are saying D dot name, this is my attribute and this is my constant. So, in the formula F1, what it says D dot name is equals to research. In the second formula, we says there exists a tuple T such that D dot D number is equals to T dot D number. So, now look at, we are comparing two attributes, but these two attributes, they correspond to two different tuple variables, or you could say since these two different tuple variables, they may come from different ranges, so they are corresponding to different relation. For example, here I am saying R1 is denoted, is the D range of D is R1, and for the range of T, I am saying it is R2, and maybe here I am having the tuple X, I am having the attribute in this particular R2 relation XYZ. So, I am saying for in the formula F2, there exists a tuple T. Now, see, there exists a tuple T, that is this relation such that D dot number, that is maybe here this particular attribute is equals to this particular F attribute. And what the formula F3 says, for all D. We need to look for all the D where D dot attribute is equals to this constant. So the tuple variable D is free in F1. We haven't used any kind of quantifier in this case, so it is free. In this case, it is free, this tuple D. But in the case of the formula, that is F2 and F3, you see D. But here it is a bound variable. Sorry, in F2 it is D is also free. But why D is free? Because this exists, this quantifier, it is working on tuple T and not on tuple D. So in the case of F2, if I talk about D, it is free. But if I talk about D, then it is bounded for this particular formula. When I come on F3, this particular quantifier, it is associated with tuple D. So in the case of the formula F3, D is a bound variable, bounded tuple. Tuple variable T is bounded in F2, which I already told you. So these are the few example queries. We will look them, certain few examples which we are going to look so to understand the concept. So here I am having a relational database schema, and in these schema I am having these tables, these relations. I am having employee, I am having department location, works on, project and dependent. And corresponding to these relations, I am having certain set of attributes. For instance, employee is having these set of attributes, department is having these set of attributes. In department location, I am having only 2 attributes, that is D number, D location and so on. So the very first example is retrieve the name and address of all the employees who work for the research department. That is name and address of all employees. So if I look on this name and address of all employees, so I need this relation and work on the research department. So I need this relation. So I am working on my output is coming from 2 different relations. In the first query, one is from employee and another one is from department. So what I need to do, first I need to specify the attributes, what need to be printed. So in this case, what I need name and address, and in this particular employee database, if you see that we have segregated the name into 2 parts. Atomic names we have, atomic fields we have created corresponding to name, that is F name and L name. So what I have done, and the middle name is also there. So T, my tuple, and this T, if you look, it is associated with the its ranges on the relation employee. So here T dot name, F name, M name, L name, and what I need to print, address. And I need another relation also, clear? But in this relation I am using for the joining part. So here what I have done, after declaring my range, because all my attributes, they are coming from this particular relation, so this becomes my range. And what is my condition now? And the condition is there exists a tuple D, and this tuple D is coming from the range department D. And how it is connected? And D dot name, that is the department name. Now my tuple is D in this case, because I am referring to the relation department is equals to research, and D dot department number is equals to T dot department number. If you look here, we are having this department number, and here we are having this department number. So here it is acting as primary key, and here it is acting as foreign key. So this we have seen. Now the second query, for every project located in Chennai, list the project number, the controlling department number and the department manager last name, date of birth and address. So manager's last name, date of birth and address, it is coming from the table employee. Then I need the project location. Project location, if I see, it is coming from the relation project. So here located in Chennai, for this I need project relation, list the project number, controlling department. For this it is coming from the relation department. So for this query I need to address three relations. One is project, another one is department and the third one is my employee. But if you look at the what I need to get printed as a output, what attributes I need to get in the output, I need these attributes from the employee relation. I need these attributes, project number, controlling department, from the department, from the department relation. So how it will work? For the project, it is coming, from the project relation. So here project number and the department number, they are coming from the project relation, and these three fields, they are coming from the employee relation. So here this is the range. This is the range. These two relations, they are working as a range for my query. And what is the condition? P dot P location is equals to Chennai and there exists a department D in the relation department such that P dot D num is equals to D dot, because I am joining, the joining is to be done between P and D, and D dot manager number is equals to M dot employee number. So in this way, the three relations are addressed and a TRC is formed. Find the name of each employee who works on some projects controlled by the department number 5. So in this case, I need F name, L name. Again, these are going to be printed from my relation employee. So this becomes the range. And there exists X and there exists W. Now there are two tuples and we have used the existential quantifier such that project X, that is, this is relation, and works on, this is another relation, and X dot D number, that is from where D number is coming, this is coming from this relation, and the employee, W dot employee number is equals to E dot employee number, and project number is equals to a project number of the relation X and W. So in this case, what is happening? We are getting these attributes in the output. From where they are coming, range is this, and there exists X and W such that X is coming from project and W is coming from the another relation, that is works on. So in this case, the first we will specify control by the department number 5. From where the department number is coming, it is coming from this. And employee number, that is each employee who works on some projects. They may be working on more than one project which is controlled by the department 5. So here what is happening? Here works on, here the employee number, it should match with the employee number which is present in this particular relation, as well as they should be working on some project. Here the project number, it is coming from my X, that is from here and here. If they match, it implies that they are working on some project. Find the name of employees who have no dependents, and for this what I am having the relation of dependent. So here I need the name of employees. Again, this becomes my range here. This is the symbol for and. You can use in certain books you will get such notation also. So here and for all D not present in the dependent D. This is very important. So not in this particular or not is equals to and whose information is not present in dependent table information. So in this way you will list all the employees who have no dependents. Important thing is that we need to see that the expressions, it need to be safe. So whenever we use the quantifiers or negation of predicates in a calculus, that is a not operator, in the calculus expressions, we must make sure that the resulting expression, they should make some sense. A safe expression in relational calculus is one that is guaranteed to yield a finite number of tuples as its result. Otherwise, it is called unsafe. For example, if we say a tuple T which is not present in employee T is unsafe because it will yield all the tuples in the universe that are not the employee tuples, which are infinitely numerous. So we could say in this case it is a unsafe expression. So what we say that the expression, it may be a range, it may be a formula, or it may be atomic, or it may be a combination of two formulas, that we should always have a finite set of tuples in our result. Otherwise, the expression becomes unsafe. So this is all about the TRC, that is tuple relation calculus, and for this I have referred these books, the slides from these books to prepare this particular lecture. Thank you and Jai Hind.